they are called diastereomers. So let's say these are called Fisher projections. And during these Fisher projections, the ones that are here look like this. And the other two are going towards the back. Okay? So these are going like that and like that. But we don't draw them that way. You just have to know that these are pointing this way. And the rest, don't worry about it. These are coming out. So let's say that I have here this, and I have that there. These two are towards the front, while those are in the back. How many chiral centers does that have?
One.
Just one.
One chiral center, that's this carbon here. Carbon has that attached, that attached, that attached, and this attached. If I want the total opposite of that, it will be like this. Yes? There are mirror images. One is the enantiomer of the other. Yes or no?
Yes.
Draw the enantiomer of this. What did you do?
Switch
Switch
the sides
it.
of the
You did this?
Yeah.
Yes.
See what you did?
No.
No.
Switch the.
No.
You just switch the OHs and
No.
the H.
H. Yeah.
What did you switch?
Yep.
The H's and the OH.
This OH here?
Yep.
Yes, sir.
And the hydrogen on top too, no?
No.
It doesn't
no.
get switched?
Hydrogen on top is not chiral.
Okay.
So you switch the chiral centers, yes?
Yeah.
From one side to the other. This is an enantiomer of that. This chiral center has the opposite on this side, yes?
Yeah.
And this chiral center has the opposite on that side. Yes or no? One molecule is a total opposite of the other. Yet if I do this, what is that of the other two?
The first on the.
Is it an enantiomer?
No.
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 It can't be, right?
No.
I mean,
First
this
yeah.
one and this one
Yeah.
has this have the same stereochemistry, but this one and this one has the total opposite. While these two have the total opposite, while these are the same. So this is a diastereomer of this, and this is a diastereomer of that, in which one chiral center changed, while the other one stayed the same.
Yeah.
Okay, let me see that again.
And most of the time, Fisher projections are used for talking about carbohydrates, okay, sugars. I want you to draw an enantiomer of this. How many enantiomers should there be?
One.
One enantiomer only.
Yeah.
I want you to draw the enantiomer of that, and then draw two diastereomers of that. Okay. You passing around the attendance?
You said 101, right? Two days. Okay, so let's draw this one, yes? We are going to draw the enantiomer of this. This stays the same. This stays the same. Total opposite of this here is which? OH on this side. Total opposite of this is?
H.
OH is this. Total opposite of that is? That, this, and these are enantiomers. Enantiomers. So let's say 1 and 2. 1, 2 are enantiomers. Let's say I wanted to draw a diastereomer of the first one. What do I do?
You can have H's.
You just change the one.
I could just
Do one.
Just do one. Just change one and leave
Just
two
do
the
one.
same.
Anyone
The one in the
One.
middle.
leave 2
the same.
the same,
and
change 1, or
different.
So do the
change
one in
2
the
and
middle.
leave 1 the same.
Right.
It doesn't really matter. So if we leave this one the same,
Change the one in the middle and then the one at the end.
and we can change
That one.
OH,
And this one?
And then leave that one the same.
OH, H.
Okay,
Mm-hmm.
yes?
Yes.
This is structure number 3. Structure number 3 is number 1 and 3 are diastereomers.
Excuse me.
How about this structure and this structure? Are they diastereomers too?
Which one?
Structure 2 and 3, are they diastereomers?
Yes.
Okay, yeah, structure 2 and 3 are diastereomers as well. So here's what's going to happen on the test. On the test, I'm going to give you 4 or 5 structures. And I am going to ask you to tell me, they're going to be numbered on the bottom, 1, 2, 3, 4, 5, 6, and 7, whatever it is. And I'm going to ask you to tell me which ones are enantiomers and which ones are diastereomers. Okay?
You said that there was 2 diastereomers, but you only have 1 up here.
Yeah, the other one is the enantiomer of the first one.
But you can make,
I can make another one, yeah.
is there, the number of diastereomers you can make, is it equivalent to the number of paracentrics you have? You can make more diastereomers than paracentrics you have?
I have no idea.
Like, how many can you make from this particular molecule?
I don't know, you tried making it.
I made 5, 1 enantiomer and 3 diastereomers. I just changed, I started to change the top, change the middle, change the bottom. So it is equivalent to the number of paracentrics you have.
Never thought about it.
How was number 2 and enantiomer of 1? I thought diastereomer of 1.
It's not.
3 is a diastereomer of 2, right?
1 and 2 are enantiomer. Can you help them that would be?
1 and 3 are
Two is a
diastereomers.
And then 2 and 3, 2 and 3.
As well.
2 and 3 diastereomers.
Is that because
Yeah.
the top and the bottom switched to like how that was? Is that why? Do you get my question or no?
You switch one while leaving some of the other ones the same, or you switch 2 while leaving 1 the same. Something has to stay the same and something has to change.
So it doesn't matter whether it's 2 or 1.
Whether it's 2, 1, or
It doesn't
3.
matter.
1 has to change, 1 has to stay the same at the very least.
Oh, okay. Either one.
You have one that's OH on the left, all H on the right side. All, that's still be a.
Yeah?
So that would be a diastereomer and then an enantiomer and that. So then what I just said is not true. It's not equivalent.
I don't know what you're saying, the things you are saying like that. I think this is hurting you. Stop eating the vegetables.
It doesn't have any vegetables.
Eat cows once in a while.
It's apples, bananas, orange, a hint of pineapple.
You must be a sad person. Okay, since somebody said this, what is this of this? This is the enantiomer.
Yes.
And if you're wearing a Rolex, this will look like this, yes?
Yes.
Yes?
Yes.
You guys did know that, yes?
I wouldn't know. What?
I don't own a Rolex either, but I will never own one after I saw a Rolex instead of with that fork, with this thing. I'm serious. That's serious.
Maybe it's not
Look
a
it
real
up.
Rolex.
It is a real Rolex. I looked at it up.
What is that thing?
Who
No.
has a Rolex? You have a show it, girl. What's wrong with you? Does it have a Roman numeral?
Yeah, it doesn't
It
have.
does, yeah, on the
What
face.
Roman numeral is it?
It's usually 4. Like, all of them have it.
The 4 lines? What a disgrace. How do you, in the right state of mind, hang around with that? Everybody's gonna know, damn, the people that did this are illiterate. They don't speak English,
Yeah,
right?
it still costs like more than my car.
Rolex doesn't cost more than, oh yeah.
Yeah, depends on the car you
Yeah,
have.
your car
It
might,
depends the type of car you have.
How
yeah,
old
yours
it
is
is.
$700.
Just because it's small doesn't mean that it costs something.
No, I'm small, I don't cost $700.
Your car's small, so does that mean it costs $700 too?
Yes. My wife's small. Okay, guys. Is that it?
He drives the wrong seat. At least that's the last one.
Is that it for that?
Yeah,
You know,
that's good.
So on the test, I'm gonna give you something to draw. By the way,
it's Volkswagen.
this type of compound is called what? What is that called?
Meso compound?
That's meso, yes?
Yeah.
Because it has a plane of symmetry. I want you to draw this in the most stable cyclohexane chair conformation.
Oh, okay.
Actually, I want you to draw it in the most stable cyclohexane chair conformation, and then I want you to draw it like this, in one plane, with the dash and the wedge.
In what plane? Dash and wedge?
Dash, wedge, and then cyclohexane chair conformation.
Okay.
You don't think I like your joke? I can hear you. I cleaned my ears yesterday. I don't have earwax anymore. I like your joke. I just don't laugh about it. Okay, what is it?
What is
Which one do you want to draw first? This one?
cyclohexane chair?
What do I do?
You draw.
I choose
the
two co-
wedges.
Huh?
You draw dashes.
Very nice. Okay, now what?
And you start putting the stuff on it.
Okay, let's draw it in another way, okay? You like that one better?
Yes.
You can draw it either way, it doesn't matter.
So how do you know what goes in and what goes out? Like what comes to the front and what goes like?
What do you mean?
The hydrogen in the
CH3
back.
and the H.
You can put it wherever you want. There's no set way. So what am I going to do with the CH3s now? Where am I going to place them?
You're gonna put one in the equatorial, one in
I mean, I can put them in the front, I'm gonna put them in the wedge.
Yes.
You can put them here. Nothing says you can't put it down here. Okay? But if you get this structure, and these two are looking up, if you get this structure, and you turn it this way, those three are pointing up. Okay? If you use these, then you get this structure, and you go like this, and then those are pointing up. You see it? So it doesn't really matter where you put them, as long as you put them both on the same side.
Yeah.
Okay? And if it is a cyclohexane chair, what do? Here you go. Tell me, where am I going to put the CH3?
One equatorial pointing down, the other one.
Let's try to make the most stable one
pointing down.
equatorial. The next one has to be the same side. Which one is it?
Axial.
Axial. Bottom, lower bond, here is lower bond. Any
questions, guys?
Wait, yeah, why did both the lower?
You want to put them both in upper bound?
No, but,
What?
no, I think because I'm thinking of the trans.
But this is not trans, okay?
Exactly, yeah, that's why.
You want to put it that way? It's the same thing as
Same thing, yeah.
What else? Anything else? Anything else you guys read in your book that I have not talked about? You guys do have a book that you read every week, do you not? All right. Let's go into a new chapter. Now that you guys know what methamphetamine is and what the Rolex has and who has a Rolex, he threw you under the bus.
Oh, don't worry. Surprised with this one.